Hello, it's Duncan. My thoughts on functional programming have been heavily influenced by Eric Normand. He wrote a book called Grokking Simplicity, which manages to hide some excellent content behind a mediocre title, a problem I know well. Eric categorizes code into actions, calculations, and data. This is a simple concept with some profound implications that have changed the way I think about programs. So let's have a look at the Gilded Rose codebase and see what it can teach us and how we might improve it. In his book and also in his podcast, Eric Normand differentiates between three elements of our programs. One is data. And in his formulation, data has to be immutable. He doesn't actually have a name for mutable data. I think of his data as values, so data that can't change. So data is represented by variables and is of types like int and pair and map and so on. So I said here that we can annotate classes, effectively types, to say that they're data. What about non-classes? What about the other things in our program? Well, they're code. And so they're functions or constructors. And there are two types of code in his formulation. One is a calculation. And a calculation is a piece of code that always returns the same output for the same input. So if it's a function and you call it with the same arguments, then it will always return the same result. Not only that, though, it has to have no side effects that are significant to our program. So if you call println, for example, with a string, it will always return the same result, which is unit. But it does matter how many times we call println, because every time we call println, something appears on the console. So println is not a calculation. Similarly, if a piece of code has to go to a database to read a value that could ever change. Also, the result of a function depends on some state that isn't represented by its parameters. So a piece of global state that might change, for example. Then it will depend on when we call it, because somebody might change that global state. So if a function isn't a calculation, then it's an action. So actions are everything else that isn't a calculation. Now, this may seem a pretty arbitrary division into data and calculations and actions. It certainly feels quite theoretical. Bear with me, because this formulation makes an awful lot of things that I've learned sort of intuitively about programming make sense. It gives me a language to talk about them. So what we're going to do is we're going to go and look through our code and we're going to annotate it. These won't live. I don't think we're going to check them in, but let's just see where this takes us. So we're going to start in our domain and let's look in ID. ID is a value class. We can't mutate it in any way. And so it is in this formulation data. What about the operations? Well, invoke here takes a value and returns a non-blank string. And it's entirely deterministic. For the same input here, it will always return the same non-blank string. Not actually the same object, but an object that will compare equal. So I think we can say that that is a calculation. It's a direct mapping from this input to this output. What about toString? It's the same there. That will always give the same output for the same input. Now you might say it doesn't have an input, but for classes I think we have to consider this, the receiver, to be an input to this function. Okay, moving on. Here's item. Item has all value properties, so we can't mutate it. So that makes item into data. Now you might say the fact that we called it a data class gave that away, but had we changed its name to a variable, for example, then it wouldn't be data because it would be mutable. Okay, there's a secret little function hiding here, our constructor. So if we put in constructor there, then we can say, is our constructor a calculation or action? Well, all it ever does here is squirrel away its parameters into these properties. It doesn't do anything else, so I think we can say that this will always return the same item, or at least items that are equals, with the same arguments. So this is at calculation. What about this constructor? Well, that's a bit more complicated because this constructor calls a function here, which is type4. Let's just lay that out so we can see it. Now, type4 is a function, but is it a calculation or is it an action? If it's an action, if it goes off and writes to a file or launches a missile or something like that, then that makes the code that calls it into an action itself. Generally speaking, if we have code that invokes an action, it becomes an action itself. So let's go and have a look in type4. Here it is. And it takes a cell by date and a non-blank string. And it just calls things that are all calculations, name, contains, and so on. So I think we can mark this as a calculation. And then with that knowledge, we can go back here and say that this constructor is a calculation. What about this updated by? Well, we'll have to look at everything it calls. We'll have to know, or at least intuit, whether local date plus days is an action or a calculation, whether fold results in an action or a calculation, whether type update results in an action or a calculation. And if all those things are calculations, then this is a calculation. And as it happens, all those things are calculations, so this is a calculation. Moving on to item type then, we've established that type 4 is a calculation. And if type 4 is a calculation, then it implies that everything it calls is a calculation, so conjured must be. And down here, I think we have type 4. This private type 4 is also a calculation. Up the top, there's an interesting thing here, which is a type. That's a fun interface. So that's a type that's defining the type of a piece of code, of a function. And so we should probably be able to annotate that as well. This will be a calculation if its single method is a calculation. An update here, well, you see, we don't actually know because it's going to be implemented by other things, but we could hint to the implementers by saying that this update should be a calculation. And we've helped them a lot here because we are taking an item and returning an item. We're not mutating the item, but of course we couldn't mutate the item anyway because item is data. It's a value that can't change. Okay, for the rest of our domain package, I've filled in the bits so you don't have to. Non-blank string is data and everything about it is a calculation. Non-negative int is data and everything about it is a calculation, including these operations here, because none of them mutate anything. They only depend on the inputs. Same as for price, quality, and stock list. So far, everything we've annotated has either been a calculation if it's callable, or immutable data if it's data at all. And so you may be saying, well, annotating everything seems a bit pointless. And I think you'd be right, except that this situation is no accident. Experience has taught me over the years to make all of my data immutable, and as far as possible to make my functions into calculations. So that now is just the way that I write code, and as I'm writing Gilded Rose, it shouldn't be surprising that Gilded Rose looks like that. So instead of confirming that everything is data and calculations, let's go looking for the places where that isn't true. I/O is a really good place to look for actions, because as soon as we save something, it matters when we do it and how many times we do it. And if we're loading something, it depends on when we're doing it, because something might have changed the thing we're loading. So here's stock list saved to file. It uses a writer on the file. And so that depends on what's in the file at the moment. So this will be an action. What about things it calls? It calls this to lines, which is here. Now, the result of this will be output in this action, but this is in fact itself just a calculation, because for a given stock list input, it will always return the same sequence of strings. We see the same relationship between this file load items, which is opening a file and will be an action, and lines to stock list, which is a calculation, because for a given sequence of string, it will always return the same stock list, or an error. Looking further down, we have item to line. Well, that's a calculation. Last modified from a string, that's also a calculation. String to instant, again a calculation. And string to item, a calculation. And so on all the way down. Note that though, if we discover that any of these were in fact actions, that they depended on when they were run, then it would make the code up here that we said was a calculation, this stock list to lines or lines to stock list, into an action itself. If something that's otherwise a calculation calls an action, it becomes a calculation itself. Now here's an interesting fact. Calculations are a lot easier to test. There are two types of test actually in our persistence test. There's this one here, which is save and load and calls stock list save to, which was our action. You can see now we've annotated it. And file load items, which is also an action. And because of that actionness, we've had to set up environment, we've had to create a temp directory, and we've had to have a file inside it, and so on. In contrast, save and load empty stock list, load from empty file, and so on, are using the calculation side, and they're quite easy to test. They can just set something up, call a function on it, and see what they get back. So ease of testing is a good reason to prefer calculations over actions. Because of the transitive rule of actions, once we've identified low-level actions in our system, we can find high-level ones by seeing what calls the low-level ones. So if we look at who calls save to, we have fixture save, stock file item save, and the persistence tests. Well, the outside two are in test, so let's not worry about those so much. But stock file item save, we now know must be an action. Now, this being stock file items begs another interesting question. Stock file items implements items, so is save in items an action? And the answer is, well, I think it is, because if we had a compiler that respected these things, in order for the subtypes to say that save was an action, the supertype would have to say it was an action, because the callers would have to know what they were dealing with. So I think we'd mark this with an action. And then if we look at the other implementations of this, we have the database items. Well, that goes off to Postgres. It does I/O as well, so it evidently is an action. And the in-memory items, well, it save doesn't do any I/O, but what it does do is it updates some state. So even though it's not doing I/O, it does matter when we call this, because saving in here will affect future loading. So we know that this is an action. And by the way, of course, we know that load is also an action because it depends on other saves happening. So in-memory items, and in fact all of our item types, are classes, are types that are not data. Previously, with things like stock list, we'd said, oh, messed that up, that this is data. So a class is often data, but classes that encapsulate state themselves are not data because they're mutable. And just returning to the I messed that up, you see that part of the problem with that little scheme here is that this is just on the honor system. I said that this was a calculation, but it evidently wasn't. The compiler has no way of checking. I'll just go and annotate actions for the items methods. So we know that this is an action. And now again, we can go looking for callers of save or load to find other actions. So now we have stock list. And this is the place where we call both load and save. So we know that it is an action. Now within this action though, we only have two other actions. We had this load and this save. All the other parts of this, for example, stock list updated, let's have a look at that. That is just a calculation. And you may have noticed that when I write code, I tend to separate these things out. In this function at the moment, we had this action that appears here, sort of down in the bowels of it. It would be better to pull that up if we could, so that our action's on the outside of all this code. What would that look like? Well, we could take this expression here and use this as something like updated or maybe updated. And that would return just the updated stock list or what was loaded. And now we can ask the question, did that actually change? So now our action bit is to say, if maybe updated equals loaded, then we're just going to return a success of either of those. They're the same thing. Else we need to save, so that's going to be items save the maybe updated that we now know is updated, and run our tests. And so we have a lot of trust in our test. That suggests the logic is the same. But now we have a nice calculation here that we could extract and crash IntelliJ as updated if out of date. Make that a receiver. And now you can see this is really nice and simple and will be a good candidate for testing on its own. So looking back up in here, you can see what we've done. If we've separated out the calculation here into its own little logic, and around that we've done the I/O. So we've done some I/O here, and right at the end here we've done some more I/O. Now that's at the expense of some efficiency, because here we're going through 2 stock lists and checking whether they're the same to decide whether to save. Whereas previously inside this code, we knew whether we had to save or not. And also this style takes a bit of getting used to. Here we're having to read between the lines a bit, but this does show that we can generally partition our code into the pure calculation bits and the impure action bits. Okay, moving up the stack again, who calls stock list? And the answer is our app, except it's not really our app that calls it. It has a reference to it that it passes to the price stock list loader. So let's look in the price stock list loader. We're passing it into this loading here. And now we have a problem that we can't mark the fact that we know that this could be, well, in fact, has to be an action, really. This needs to read the stock list from somewhere. It can't magic it out of thin air, so we know that it's reading it. So we can't really express that actionness of a function type here. That's a problem we'll look into in another episode. But I think we can say that we know that load here will be an action. In fact, the price stock list loader is using 2 actions. It's using the first one here, which is loading the initial stock list, and then it's going off to a network service to price up the item. So we know that this item priced by something here is going to be action E at the very least, and this pricing is itself going to be an action. But as you can see, when we start passing around function types, we get into issues with our labeling. And those of you who use coroutines will recognize some of these issues with functions and suspend functions. We'll gloss over that for now and look back up again at this action to find out where it's called. That's app load stock list. So this is evidently an action. Where is it used? Well, it's used in this roots for, which takes it as a function type. And that's passed down into this list handler here. And this list handler combines 2 actions. So the first is clock. By definition, if we're asking the time, that will depend on when we ask it. And this listing here we know is an action. The stock list we get back will depend on what's on disk, which will depend on when we load that file. Render, however, is a function that takes data and data and data, and everything that it does is a calculation. It calculates what the HTML should be, and for a given time that we're passing in, and a given stock list result that we're passing in, and a given zone ID will always return the same result. So this is helpfully a calculation. And that's one of the reasons that rendering was so easy to test. In our rendering tests here, we didn't have to set up a mock clock or write things into disk. We just created the inputs into our render function, call it, and assert something on the result that we get back. So now I hope you can see why we've been so fastidious with passing now around in our code. We still do have a clock, but even for something that's fundamentally an action because it's going to do I/O, we still pass the current time in because that means that all of our actions will at least be sharing the same current time. And that solves some of the problems I've seen in production where half of a piece of code runs one side of midnight and the other half the other side. Moving back to roots, it's interesting that we can often tell from a function signature whether it's an action or a calculation. So for example, the signature of our clock here is nothing to instant. Well, functions that magic a value out of nowhere are probably actions. Now that's not always true. They may read from an immutable global variable, for example, but it's a good guideline. While we're there, if we look at analytics, analytics is the opposite. Analytics is something that takes an analytics event and returns unit, so it consumes the thing. Now, assuming it doesn't just do this for fun, we know that a function with this signature is going to have a side effect. And if it has a side effect, then it matters when it runs. So our analytics is in fact an action. And if we go back and back again, you'll see we default here to stood out analytics, and anything that writes a standard output we know must really be an action. Something's going to appear on the console, and it matters when or whether we do that. Our analytics, though, is a bit of a special case. Do we want something that is otherwise just a calculation, but happens to log an intermediate result, to be an action because analytics is an action? Well, that's a bit of a grey area. I tend to think not. I'll treat analytics and logging as a special case. But one of the reasons I'm happy with that in this code base is that the analytics is pushed quite a long way up the stack. So if we look at what uses analytics, we use it in our price stock list loader here, And we have to have it here really because we wanted some way of reporting that we are retrying failed calls. And that kind of is by definition side effect. So where is analytics used here? Well, it's down here in report exception. But it's quite harmless in the price stock list loader because we know that it's going to be called in the context of things that are already actions. So that's all right. Another place we might expect to see use of the analytics is when we're loading items and get an error. But instead of that, we use our error type here, this result, to capture the information about our error. That in turn is passed up here through our stock list method of stock. Now that makes its way here to render. And in the case of an error here, we're setting the error onto our response, and this response is just data. And then finally in our routes, we have a filter here, whose job it is to report those errors to analytics. So whilst logging to analytics is a side effect, it's pushed as far as we can to the outside of our system. In the meantime, all we're doing is passing data around. And in the case of an HTTP response, we're attaching data about the thing that we want to be logged to that response. And the point of that design was to minimize the fallout from these side effects. I was about to wrap up here, but I noticed that in the course of recording this, I've added annotation target property to our calculation. Let's just see why. Well, it turns out I've annotated this property here, value int, in our quality class. Let's go and have a look. All properties in Kotlin are actually calling a function that returns a value. But non-computed properties, normally things like this value here, they're just returning the value of a field. And providing that field can't be mutated, then they are calculations because they'll always return the same result for the same input, the receiver. Computed properties, though, are a bit different. We could write any code in here. So we could write if local date now is leap year, value, else 0, say. Now a property will depend on when we call it, and that's an action. But note that we haven't allowed actions to annotate properties. Why is that? Well, it's because one of my rules of thumb for Kotlin is that if I'm going to write a computed property, it had better be a calculation. I don't want them returning different things at different times. So if you're wondering how to decide whether something should be a function or a property, this is a good guideline. If it's always going to return the same result, then property is good. But if it can return different results in different circumstances, then that's an action and should be a function. So to wrap up then, we can characterize our code as immutable data. There's also immutable data, but we should try and avoid it. Calculations, which functional programmers would call pure functions, and also referentially transparent, which means that we can replace a function invocation with the value that it always returns. And there are actions, which are everything else. And without special pleading, any code that calls an action is itself an action. The nice thing about calculations is that we can move them around our code. It doesn't matter when we do them. And that means we can refactor very easily if we're only using calculations. Actions, on the other hand, if we reorder them as a result of our refactoring, we can change the working of our program. So on the whole, calculations are a lot more reasonable, which is to say they're easier to reason with. And so as far as possible, we like to keep actions out of our code base. Now we do need them because we need to have an effect on the outside world, but the trick is to move them to the outside of our code so that more of our core can be pure calculations. Okay, I think we're done for the day. I'm going to check this into a separate branch that I'll link to in the show notes so that when we come back for the next episode, all these annotations will be gone, but we'll look at whether we can distinguish between actions and calculations using context receivers. I think that's a really interesting experiment. And if you'd like to follow along, then please subscribe to the channel and like this video so YouTube will tell other people to watch it. If you like what I'm doing, I'm also available to hire. My contact details are in the show notes. And I think you'd enjoy the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.